will start discussing area and definite integrals and how they are related. Let's start by considering a function. And we want to know what the area under this curve is. And we do this by taking Riemann sums. Essentially, we break our interval up into different pieces and look at rectangles. And we can see that this is not perfect. We have some areas where we overestimate and some areas where we underestimate. So we are not perfect. We do have some area. However, as these rectangles get smaller and smaller and smaller, that area or that error gets smaller and smaller as well. So if we break this up into rectangles and then take the limit as we go to infinity rectangles, we will have the actual area. This idea is called a Riemann sum. The idea is we want infinitely many rectangles, so we're going to take the limit as n goes to infinity, and then we're going to add up the area of each individual rectangle. This f of t sub k star, this is going to be the height of the rectangle, and then delta t is the length of the rectangle. In general, our delta t is going to be equal to b minus a over n, where a and b are the endpoints. And the t sub k of star is some kind of sample point in that interval. This can change depending on if we want to deal with a left interval, a right interval, or a midpoint. Before we actually evaluate these sums, we should know some of the basics. The first one is if I add from 1 to n of just a constant, then we have bn. If I add up from 1 to n of k, so 1 plus 2 plus 3 plus 4, etc., we have n times n plus 1 over 2. And then adding from 1 to n of k squared, so now 1 plus 4 plus 9 plus 16, etc., will be n times n plus 1 times 2n plus 1 over 6. And we will use these in our example. Let's now look at our example. We have this function 3 minus 8t plus t squared between 1 and 3. So we're going to start with our sum that should go from 1 to n of our function. So f of t sub k star. And t sub k star, we're going to do right endpoints. So we're going to start with our starting point plus k delta t. And then we would have plus 1 plus k delta t squared, all times delta t. So this comes from 1 is our starting point from our interval. The k delta t, the delta t is the width, and the k tells us which of these intervals we're on. We're then going to multiply things out and simplify. This would be 3 minus 8k delta t plus 1 plus 2k delta t plus k squared delta t squared, all times delta t. We can then simplify. 3 minus 8 plus 1 is negative 4. Negative 8k delta t plus 2k delta t would be negative 6k delta t. And then we have the k squared delta t squared delta t. Using our rules for summations, this negative 4 would be negative 4n. This would be minus 6 delta t, and then the summation of k was n times n plus 1 over 2. This last one, we would have the delta t squared, and this k squared Well, for k squared, we had n times n plus 1 times 2n plus 1 all over 6. And we should be multiplying all of this by this delta t that comes at the end. And now we're actually going to start taking limits. And we'll start by actually multiplying through by delta t. When we do, this right here is what we get. So remember, delta t was b minus a over n. And since we're looking at the interval between 1 and 3, we would have 3 minus 1 over n, or 2 over n. So this would be negative 4n times 2 over n, minus 6 times 4 over n squared, times n plus 1 over 2, and then plus 8 over n cubed times n plus 1 times 2n plus 1 over 6. And now we're actually going to take the limit as n goes to infinity. Our first term would become a negative 8. Here, our limit is actually going to be negative 12. And our final one, our limit would be 8 over 3. So now we can simply add these numbers up. This calculation was quite cumbersome. However, we do have ways to abbreviate things using our definite integral. So we use this elongated s to represent that we're going to sum. We would do a 1 on the bottom and a 3 on the top, which are our limits. The 1 would be called the lower limit, and the 3 is the upper limit. We would then do our function, f of t, which is known as the integrand. And then we do dt, which is called the differential. And this would be the shortcut to explain that we're going to add up these rectangles between 1 and 3 of our function. And this is our notation for a definite integral.